Make sure your book is open to page 759. Make sure that you actually have a pencil in your hand and you'll be writing down what I write down when I write it down and following along and answering the questions. So, this is the teaching part of our day. So, make sure that you're actually paying attention, looking at the screen, and writing in your book. All right, so we should be on page 759, and this is chapter 9, lesson 9, which is concerning the volume of rectangular prisms. So up to this point, we've been working with area, which is a two-dimensional concept where we figured out how much space in square units is inside different types of shapes, different types of polygons like rectangles and triangles and uh, trapezoids. Now we're going to be working with three-dimensional objects, and that's not area, that's going to be volume. So what I'd like you to do is go ahead and jot down the things that are in these boxes describing what volume is. Volume is the amount of space that's inside a three-dimensional figure. And so basically you're going to, anytime you fill something up, like fill up a pitcher with water, fill up a bathtub with water, fill up a jar with candy, these are containers that hold other things, and what is inside those three-dimensional containers is volume. So an example, how much space is inside an aquarium? So how much water would you need to fill up an aquarium? A non-example is going to be how much space is needed on the top of the table or the floor that holds the aquarium, because that's going to be a flat shape, and that's going to be square units and not cubic units, which we're going to talk about here in just a moment. Okay, so here at the bottom, this is an example of using the formula to figure out what the volume of something is. It is going to contain length times width, which is how we do area, but we're also going to consider height, like how tall the three-dimensional object is. So the area of the base is 6 square feet. The height is 2.5 feet. So I'm going to go ahead and turn my pen on here. And so to solve that, the formula is going to be length times width times height. So length times width is 6. And we're going to multiply that by 2.5 feet. But anytime we multiply something that has a fraction, we have to actually, if it's a mixed number, we have to make it into an improper fraction. So we're going to put the 6 over the number 1. We're going to say 2 times 2 plus 1. So what is the numerator going to be? Go ahead and tell me that, please. Very good. It's going to be 5. So it's going to be 5 halves. All right, so I'm going to start by simplifying first. So I know that 6 and 2 are even numbers. So what can we divide them both by? Answer that, please. Very good. By 2. So we're going to 2 divided by 2 is 1. 6 divided by 2 is 3. 3 times 5 is 15. And so it's going to be 15 cubic units, and that's going to be shown by putting the number 3 in the air instead of the number 2, because that would be squared, and we're talking about, instead of just a square, we're talking about cubic units, and this is supposed to be a cube. Kind of, looks kind of like a cube. All right, so let's go ahead and turn to the next page. Okay, so we've turned to the next page, and it's going to describe how to find the volume of rectangular prisms. So just like with area, we're starting out with very simple rectangles. Now, if you look at the formulas here, volume is equivalent to the length times width, which is the formula for finding the area of a rectangle, but then we're going to multiply it by height. And another way of saying that is capital B. So instead of lowercase b for base, capital B is the same as length times width. It's the same as the area of the base. So the area of the base, capital B, times the height is a simplified way of doing this. So you see the model here. It's really important that you guys actually go back and look in your books and read through this information yourself. I'm going to read it quickly through here. It says a three-dimensional figure has length, width, and height. A prism is a three-dimensional figure with two parallel bases that are congruent figures. A rectangular prism, the bases are congruent rectangles. So there are such things as triangular prisms and pentagonal prisms, but this just so happens that the top and the bottom are rectangles. Okay, so the volume is the amount of space that's inside the three-dimensional figure, and it's measured in cubic units. So you can see these three-dimensional cubes, like sugar cubes or like dice. They're all stacked together, and we would figure out the volume by multiplying to find the area of the base, and then how many layers is going to be depend on the height of the object for the rectangular prism. Decomposing the prism tells you the number of cubes at a given size that it will take to fill the prism. The volume of a rectangular prism is related to the dimensions length times width times height. So you can see here that's one level, and you would actually just keep stacking it however high the base is. Okay, and so again, the number of rows of cubes needed to fill the prism is the height, and the capital B is the area of the base, which is length times width. Okay, so now we're going to look at an example they've done for us, and then we're going to practice a little bit before moving on to the next concept. It says determine the volume of rectangular prism. We're going to multiply the length and width of the base to find its area. So that's what the capital B is. So that's going to be 12 and 3/10 times 10 and 1/10. And if you struggle with multiplying by decimals, please come see me at Math Help. And so once they've calculated that, it was 124 and 23 hundredths. Then we're going to multiply that by 6, which is the height, so the number of layers. We're going to have 6 layers of this 124 and 23 hundredths, and then that's going to be 745 and 38 hundredths is cubic centimeters. So instead of just square centimeters, again, I'm going to try my best to make a cube here. It's going to be cubic units, cubic centimeters. Okay, so let's go ahead and work on these two together. So the first thing I'm going to do is determine the area of the base, and this is 555. So basically this is going to be the volume of a cube. Okay, so a three-dimensional square is called a cube. So what is 5 times 5? Go ahead and answer that for me, please. Very good, 25. And so if I come back up here to the formula, the capital B, the area of the shape at the bottom, area of the base is going to be 25. I'm going to multiply that by the height, which is 5. So go ahead and solve that for me. I want you to take 25 and multiply it by 5. So we end up with 125, but again, the units are going to be not just inches, but cubic inches. We show that by the exponent 3. So 5 times 5 is 25, put the 5 down, carry the 2. 5 times 2 is 10, plus 2 is 12, so it's going to be 125 cubic inches. So we'll do the same thing for this. So tell me what the area of this rectangle on the bottom is. Go ahead and solve that for me now. Very good. 4 times 10 is 40. And then we're going to multiply that by the height, which is 6. So go ahead and solve that. What is 40? I'm going to go ahead and write that down here. What is 40 times 6? Okay, this is something we can solve on our heads because anything you multiply that is a multiple of 10 is going to end with a 0. So 6 groups of 40 is the same as 6 times 4 is going to be 24. So it's going to end up being 240 and feet, but it will be cubic feet. And so we'll have the little 3 up in the air here. Okay. So the next example is only slightly more complicated because it does involve fractions. So don't panic. A cereal box has a dimension shown. What is the volume of the cereal box? So we have either this formula, which is length times width times height, or we can say, base, capital B base, area of the base times height. So 3 1/4 times 8, that's going to be what we use to find the area of the base, and then we're going to multiply that by 12 1/2. Okay, so 8 times 3 1/4 times 12 and 1/2. And they made this into an improper fraction, 8/1. And then we have 3 times 4 is 12 plus 1 is 13/4. Then we have 12 times 2 is 24 plus 1. Now you can see they've done some interesting like simplifying here, which might be a little confusing. So I'm going to rewrite this so we can see what they've done because they kind of skipped a step that may make this a little confusing. So if we multiply, okay, I'm going to rewrite this. Okay, now. So if we simplify this, 4 and 8, there are 2 4s inside the 8, so that becomes a 2. And this becomes 1. Okay, but then we have this and this. And there is 1, 2, and 2, so that becomes a 1. And that becomes a 1. Okay, so that's why this ended up being 1, 1, and 1. So in the end, to solve this problem, all they had to do is multiply 13 times 25. All right, so at the bottom here it says determine the volume of the container that measures 4 inches long and 5 inches high and 8 and 1/2 inches tall. So the first thing we're going to do is we're going to multiply the 4 times the 5 to find the area of that rectangle. I don't know why I had a hard time finding that. So what is 4 times 5? Go ahead and share that with me. Very good. The answer is 20. And then we're going to multiply that times 8.5. In order to do that, we have to make the improper fraction. So what is the numerator going to be? The denominator will be 2. So 8 times 2 plus 1. Go ahead and tell me what that's going to be. Okay. That's exactly right. That's going to be 17. Really? Okay. So before I multiply this, I'm going to simplify. Can 2 go into 20? And the answer is yes. That can go in there 10 times. And 2 can go into 2 once. So 10 times 17 is what? Go ahead and answer that for me, please. Very good. The answer is going to be 170 cubic inches. Okay, that was weird. I'm going to write that again. 170 inches. My pen's doing weird stuff again. And then the 3 as the exponent. Okay, very good. All right, don't forget to look at the last example. And this is very similar to what we've been doing before. They're going to give you the volume, and you have to figure out a missing piece, like either the length or the width or the height. So you need to know the volume is equivalent to the length times the width times the height, or capital B, the area of the base times height. They're telling you that the volume is 102 and 9/10, and we know what the base dimensions are, the length and the width, but we don't know what the height is. So you're going to set up the problem so that you know the volume is equal to 6 times 4 and 9/10 times h. We multiply the 6 and 4 and 9/10 and we get 29 and 4/10 times h. We divide both sides by 29 and 4/10 and we end up with h is equivalent to 3 and 5/10. So that's very similar to the things we've been doing before. The only thing volume has that's different is it adds an extra factor to the formula. Okay. All right. So let's think about the important things that we learned about. We know that area is something that is two-dimensional. Volume is three-dimensional. We learned what the formula for finding the volume of a rectangular prism is, and we practice that. Think about what is something important that we need to remember from this lesson. Go ahead and answer that for me, please. Very good. Thank you for your thoughtful answer. Please come to class. We'll do some examples together.